Our ancestor, his name was Taumata, and he landed on our shores around about 1250 AD. He came from a hot area or warm place. He was looking for that heat that he had come from. His descendants have lived there ever since then. And so for us, it's always been a taonga or a treasure as part of who we are as a people.
This project is the most exciting thing that has been happening to New Zealand for a long time, at least 50 years. We are testing if we can have energy that is coming from the heat that is generated by our land.
When you go deeper, you get hotter. When you get hotter, you get more energy. But at a very specific point known as supercritical, and it can be defined by a scientist very precisely, 374 degrees at 220 bars, you get a bigger bang for your buck, much bigger, maybe 3 times as much energy out of it. And it's essentially unlimited. It's not an alternative to wind, solar and hydro. It's actually a natural complement because of the baseload issue. The baseload means keeping the machine running 24/7, 7 days a week, 365 days a year.
Because if we can deploy geothermal everywhere, you can also reduce drastically the fossil fuel use.
It's low emissions, and a lot of the fluids can be re-injected into the ground. So environmentally, it's a very attractive proposition.
So we're trying to drill to 4,000 to 5,000 meters, which is significantly further than we've ever gone before. We then are going to encounter very high pressures and temperatures, which is going to challenge the equipment and integrity.
We've chosen this site for this new exploration in New Zealand, following decades of work to understand the geology. There is probably a shallow intrusion, so a pocket of molten rock underneath the crust at that specific location underneath Rotokawa. And this brings heat really close to the surface. And that is why we're going first to drill in this site.
New Zealand has been doing this for a long, long time. I was taught by very early pioneers in the geothermal industry. They've got New Zealand standards, which is actually a rare document, so that's used internationally as the kind of substitute international code for doing it. I make it sound hard, and it is, but we've learned how to deal with all these things. But then going to supercritical is just that next level. You're trying to wrestle something out of Mother Earth, and she holds all the cards.
It is not a commercial project. What we're trying to do is to prove, first of all, the technology is up to this, and secondly, to be able to bring the fluids to the surface for our engineers and world-class scientists to analyze. That is the essential first step towards the commercialization of this.
We've got to learn a great deal and put that on the table for the commercial entities to follow. So government is absolutely fundamental to getting this started.
Well, I think the foundation of any good project is partnerships and relationships. And if we can harness that effectively, we can really change the dynamics of energy to power the whole of New Zealand.
Our consideration is that irreversible damage of our reservoir is out of the question. We can't permanently damage Papatūānuku, Mother Earth, or the resources that we have. Where our reservoir looks after us, but it's our responsibility to also look after our reservoir.